So we're going to use the graphing calculator to find critical numbers and the extrema. First up, you're going to want to graph the function in your calculator. So using the graphing calculator, typing in the function x cubed minus 2x plus 4. Then you want to look at when the derivative is equal to 0 or does not exist to get the critical numbers. So using the graphing calculator to graph the derivative, using the derivative key, derivative with respect to x of the function that you graphed, which was f1 of x. You see where the graph of the derivative. We want to look at when the derivative is equal to 0, so we'll analyze the graph at 0. Getting the graph's derivative at 0, so that's the location negative 0.816, and getting the other 0 on that derivative graph. And the other 0 is 0.816, so those are the two critical numbers. Then the third thing you want to do is to analyze where is the maximum and the minimum located. So from your regular function, calculating out the maximum, and calculating out the minimum. So the maximum at x is equal to negative 0.816 with the max value of 5.089, and the minimum is at 0.816 with the minimum value of 2.911. So then just sketch a graph on your paper, identify the critical numbers, identify the relative max and the relative min. And noticing from the graph there's no absolute maximum and no absolute minimum. So again, with our calculators, we're going to graph the function 1 over the fifth root of the quantity 1 minus x squared squared. So we graph the function. Then we're going to graph the derivative of the function to look at where the derivative is either equal to 0 or does not exist. So the derivative with respect to x of that f1 of x that we graphed. And the derivative doesn't exist at those asymptotes at x equals negative 1 and 1. And the derivative is 0 when x is equal to 0. Then using the original graph, we'll find the minimums or the maximums. In this case, there's only a minimum at 0, 1. So we'll draw a sketch of the picture of the function, as well as writing out where the derivative doesn't exist or where the derivative is equal to 0 to identify our critical numbers. So we have critical numbers at x equals 0, x equals negative 1, and x equals 1. There are no relative or absolute maximums. There's no absolute minimum in the graph, but there is a relative minimum located at 1, 0. At 0, 1. Now we'll graph the function g of x as x plus 1 over the quantity of x squared plus 2x plus 2, and then also graph the derivative to see where the derivative is equal to 0 or does not exist. You can see from the derivative graph, crossing the x-axis in two locations. One derivative equal to 0 is at negative 2, and the other derivative equal to 0 is at x is equal to 0. So for our two critical numbers, we find that at x is equal to 0, that's a maximum. And the max value is 0.5, and at the other critical number x is equal to negative 2, there's a minimum, and that location is at negative 0.5. So sketching a graph of the derivative and identifying where the derivative is equal to 0, identifying the two critical numbers at x is equal to negative 2, x is equal to 0, and the absolute max located at 0, 0.5, and the absolute minimum at negative 2, negative 0.5. For our next function, we're going to graph the x squared times the square root of 3 minus x. And again, also graphing the derivative. Identifying the critical numbers at x is equal to 0 and x is equal to 2.4, as well as at x is equal to 3, the derivative does not exist. From using the calculator, we find out that there's an absolute minimum at 0, 0, and an absolute max at 2.4, 4.46, We think there's an absolute minimum at 3. By checking the table, we can see at 3, 0 there is an absolute minimum. Sketching the graph on our papers, we can see we have our critical numbers at x is equal to 0 and 2.4. That's where the derivative was equal to 0, and x is equal to 3. That was where the derivative does not exist. There's a relative maximum at 2.4, 4.462, and an absolute minimum at 0, 0, and 3, 0. For the last function, we're going to look at a piecewise graph where we have 3 minus x for the values of x less than 0, and then 3 plus 2x minus x squared for the values x greater than or equal to 0. In the graph, we can see that we'll possibly have 2 critical numbers, the sharp turn at 0 and the maximum at x is equal to 1. By graphing the derivative, we can verify. We can see the derivative does not exist at x is equal to 0. The derivative from the left and the right don't match up. And then checking to see the derivative equal to 0 at x is equal to 1. And we do have a critical number at x is equal to 1 because the derivative is equal to 0 at x is equal to 1. Then by hand, taking the derivative, looking at the limit as x approaches 0 from the left of the derivative, we get the value of -1. And the limit as x approaches 0 from the right of the derivative, we get the value of 2 minus 2 times 0, which is equal to 2. So the derivative from the left does not equal the derivative from the right. Therefore, the derivative at x is equal to 0 does not exist. So the critical numbers occur at x is equal to 0 and x is equal to 1. And then we find we have a relative maximum at 1, 4 and the relative minimum at 0, 3. There's no absolute maximum and no absolute minimum.